Today we are going to perform the experiment servo stabilizer. Now this setup is designed to study position control system called servo stabilizer, or we can say servo mechanism, and it comes as an automatic control system. It is a closed loop control mechanism which maintains a regulated constant voltage output in spite of fluctuations at the input or load. So they are mainly used for high output accuracy, typically plus minus 1%, with input voltage changes up to plus minus 50%. Now here in the kit, what you see here is there is an auto transformer. This is a torrical core auto transformer, a servo motor. Then we have a bridge rectifier, attenuator, and then we have an op-amp which is used as a comparator. Now what happens in this case is that the input voltage is given to the auto transformer, and you can see here there is a visor, and this moves on the winding of the auto transformer, and the output is taken out from one end of the visor and the another end is taken from the neutral of the auto transformer at the output side. Now what we are doing here, this is given to the bridge rectifier because 230 volts is AC supply, and for an operational amplifier or the comparator we need a DC. Therefore a bridge rectifier is used to convert AC into DC, and an attenuator is also used, the purpose of which is to low down the signal, because at the end of the, you can see the operational amplifier, we have to lower the value of the signal. Now the attenuator lowers the signal. Now what is happening here is this comparator, in this case there is a reference input which is set to 230 volt, and suppose the voltage falls, the input supply, there is a change in the voltage, and suppose the voltage changes to 200 volt. Now this is feedback to the input side of the comparator, and what happens here is, if you take this is as V in and this as V reference, so what is happening here is that V in is less than the V reference. So what will happen, that in this case the top, this transistor will be conducting, and this transistor is NPN and type, and the lower transistor is PNP type. So at one time only one transistor will be conducting. Now this conducts because of this signal, this transistor conducts, and this drives the servo motor, and the servo motor is connected to the visor of the transformer, which moves this visor to the top portion of the winding to increase the voltage to 230 volts, and the voltage correction is applied. Similarly, when the voltage goes beyond 230 volts, in that case what happens is that V input becomes greater than V reference, and in this case the lower transistor is conducting, and the servo motor moves the visor downwards the winding so that the increased voltage is decreased and the voltage correction is applied so as to maintain the voltage at 230 volts. Now there is one more thing that I want to show you, and this is the auto transformer. And when we change the settings, so that to show you that how the visor moves on an auto transformer. So this is the winding of the auto transformer, and this visor actually is moving for the voltage correction to be applied at the output when there is a change in the input voltage. Now there are certain measurements that we are going to perform in this experiment, and you can see we are going to use a multimeter for that purpose, and you can see that we are going to measure the voltage. Now in this case, first of all we switch on the supply, and then I am connecting this to the ground point, and there are three measurements that we are going to take. This measurement, the first measurement is of the voltage V reference, that is VR, and you can see this is coming out to be 3.6. And what you see here is, okay. Now this is again, then we are going to make the another measurement, that is the voltage Vs, and this voltage is coming out to be 3.5, as you can see in the multimeter. And then is one more measurement that we are going to do is the voltage, that is feedback, that is Vf, and this is we are going to measure at this point, and this voltage is coming out to be 7, or almost 7, because 6.8 and it is fluctuating 6.8, so we are going to take it 7 volts. Now you can see the readings that I have written, and these are the observations that we have done, and the gain that is taken in this case is 60. Of course you can change the gain with the help of the knob that is available in the kit, and these readings are taken for the 3. For the gain K is equal to 60, where VR 3.6, then Vs 3.5 volts, Vf 7 volts, and then we have found out the steady state error E, that is given by the formula VR plus Vs minus Vf, and that is divided by VR plus Vs, and when you substitute the values it comes out to be 1.4%. So this is the error that we obtained. So this is all about the experiment. Thank you.